Hello, my name's Sarah Grajdura. I'm a PhD candidate at UC Davis in civil and environmental engineering. And today I'm going to be talking about equity in wildfires in California, specifically surrounding the 2018 Camp Fire. So I aim for this to be more of a broad overview of some of the research I'm doing and some of the research I'm doing in progress. Here's an outline of what I'm going to be talking about. First, I'm going to introduce the topic, and then I'm going to go into some of the literature that is specifically related to equity in wildfires. Then I'm going to go over a couple different chapters of my dissertation so far. So I'm going to talk about the data I collected. Then I'm going to go talk about some different things that I've been modeling. And then I'm going to go back and overview some of the equity considerations that those bring, and then I'm going to talk about some of the research I'm doing now. And I should mention that, so my advisor is Deb Niemeyer, and she was at Davis and now she's at University of Maryland in College Park. Okay, so I'm just going to start here. So us all being in California, we are pretty familiar, not all being in California, I'm sorry. We are familiar with wildfires and the damage that they have been causing. And 2020, this past year, was the largest wildfire season in history, in recorded history. The 2019 season was a little bit milder, but then again, the 2018 season was also very deadly. And it was the deadliest on record. And that's actually when the Camp Fire occurred. And because we have developed in California in so many areas that had historically burned naturally, we do have a strong reliance on fire suppression. And especially because there is so much population growth in the wildland urban interface, or the WUI, we even have a bigger reliance on fire suppression to protect people who live in those fire-prone areas. And there's a large body of literature that talks about how the people who are most vulnerable in a community are actually the ones that are hit hardest during the natural disaster. And it might not even be the natural disaster that is going to be most tragic for them. It could be what they have to go through afterwards. So I'm going to move in. Oops. There we go. So I'm going to cover a little bit of the literature. So as I just mentioned, fire suppression is a tool that's been used heavily in California. And I just really want to like these images here, because on the left, you can see the Oakland Hills. This is when it was logged in the mid 1800s. And you can see on the right here, that whole area is covered with houses now. And so this area traditionally would burn, and a lot of the indigenous people, fire was part of their lifestyle. And it wasn't until we came in and started building houses in that area that fire wasn't really considered when we were populating these areas. So some of the recent literature on this, it notes that suppression is needed for these kind of vulnerable landscapes. So like when we do build houses in these areas, and also much of the housing stock, people are mostly financially secure in those areas. However, 10% of the housing stock is found to be socially vulnerable. And research has also shown that census tracts that have a majority of minority inhabitants, they're actually 50% higher chance of wildfire. And then also socially vulnerable people who are living in very highly populated and structurally dense areas, they can be more at risk for wildfire due to difficulty during evacuation when they live in very populated areas. So there's been some really interesting, very recent research about equity in wildfires, especially looking at California. So a recent study actually found that the main driver of fire suppression was to protect homes. And an article by the same authors also found that by looking at how government money was put into suppression and where it was actually like the means that were the fire suppression activities, by looking at where they were located, they actually found that they were located in wealthier neighborhoods. And they found that there was actually unequal fire suppression of homes based on how wealthy the neighborhoods were. And a similar report also showed that the agency Wildfire Prevention also does favor wealthier areas. And then there's also some current research that's looking at how the de-energization disproportionately is affecting vulnerable communities because up in Northern California, PG&E is actually preemptively de-energizing lines when there are high wind events. And when they do that, although they're doing it to prevent wildfires, when they do that, it can disproportionately affect vulnerable people who maybe don't have enough money to go out and buy a bunch of other food because all their food is gone now, or older people who maybe need electricity to be hooked up to oxygen and stuff like that. The social science literature also has some interesting point of views on equity in particular. So there's the idea of facilitation of safety for those who have resources, and at the same other side of the coin, kind of the marginalization of others. So we use all of our resources to protect these people who do have houses and stuff, but we're not actually putting suppression or other resources towards people who don't. Another interesting point that was brought out was that if you're renting and you're low income, you don't really have the capability to modify your landscape like around where you live, because chances are you can't change the outside of your apartment or the landscaping around it. Another point is that shelter in place is kind of exclusionary because it's focusing on sheltering in place. So if you don't have shelter, then you're excluded from that because it's assuming that you have somewhere to shelter in place or you have a home. And then there's been some recent research that has come back and said, well, even if people do have resources, they still are vulnerable. So moving away from that. So the data that I actually ended up collecting in 2018, in early November, PG&E in Northern California had, here I'll show you where this map is. Up here in Northern California, they were having some very high wind events, and there had been talk about de-energizing some of the lines, and they actually did not end up shutting off the lines. What they did, but unfortunately, a transformer ended up kind of exploding and sparked this fire, and they had very high wind events. So the fire spread very fast, so we can kind of classify it as a no-notice wildfire. And that's different from other wildfires that you might have previous warning ahead of time. This was an extremely fast event. So for the data for this, I was able to collect a mixed mode intercept survey of people living in the shelters after the evacuation. And also I deployed it online. And so the survey covered a lot of different topics. It covered people's evacuation, And then it also covered where they went afterwards. It covered their housing, a bunch of different socio-demographics. It covered their plans for the future. And then we were able to loop back and talk with those folks again about 7 months later. And we had a response rate of the second survey around 40%. So this was a really interesting experience because I got to kind of stay at the, not sleep there, but I got to stay at the shelter up in Chico where all the evacuees were living. And I got to go there every day for like about a month and talk to all these people. So I ended up doing about 150 in-person interviews and also did surveys with these people. And then we also, like I said, deployed the survey online. So our total sample size was around 450 and around 33% from the shelter and the rest were from online. And then of those that I did in person, I was able to get 26 recorded in-depth interviews that I was able to record. And at the left here, you can see just some pictures of the survey. So the top was the survey 1 and the bottom one was survey 2. And survey 2 really focused more on housing and where people were living at that point in time, and then where they had been living for the past 7 months. And our survey 2 is more heavily skewed towards those people who are online. We only got around 11% of the people who I had initially talked to in the shelter. Okay, so now I'm going to present some of the research that I've done using this data. So again, here's the map, in case you're not familiar with the area. Butte County is in Northern California, and it's outlined here in brown. And this dotted line is the extents of the campfire, and the community right here is Paradise, which is kind of the well-known one, the most in the news. But as you can see, the fire actually burned all these other smaller like mountain communities around here as well. So the first question that after talking to all these people, what I was really interested in was what was affecting people's awareness time, like when they found out about the fire, and then when they ended up leaving, and then the difference in time between those two. So what I ended up doing was creating 3 linear regression models for awareness time, departure time, and delay, and you can think of the delay as also preparation time, because it's the difference in time between when you find out about the fire and then when you end up departing. So here's a visualization of some of my data. So here in blue, you can see the awareness time. And I have this, it's in a blue circle here. The departure time is in a green circle. And then here, the red is evacuation notice. And that's another thing I was also interested in was, because from talking to people, it seemed like the evacuation notices, many people didn't get them. And many people were having trouble with their phones that day. And it turned out that a lot of the cell towers actually went down. And that's why people's cell phones were kind of rendered not useful because they just couldn't get signals. So the evacuation notices weren't really getting through to people. So this red is if it's a smaller percentage of my sample, but it's if the person did receive an evacuation notice, which I think only like 25% of my sample even did receive any kind of notice. So here you can see the difference between the awareness time and then departure time. And you can see, so this goes everywhere from 6 a.m. to 7 a.m. and then it goes all the way to 1 p.m. to 2 p.m. The fire started in the morning. Which was an issue because a lot of people were still sleeping in the morning. So they weren't, even if they were signed up for notices, they might not have actually been awake to hear them. So I found some interesting results here. So this plot right here, this is just plotting my data. So the red is the awareness time. The green is if they received an evacuation notice, which I explained earlier. This isn't all the same people. This is only around 20 or 25% of the people in my sample. And then the blue is the departure time. So you can see the difference between the red and the blue line is what I was kind of referring to as the delay or preparation time. So you can see the awareness time is earlier, and then later on they're leaving, which is shown by the blue line. So I found out that from my research that the method of finding out about the fire was affecting like the timing of when people found out about it. So I looked at if people found out about the fire in person, which means they saw it in person or they smelled something, they had an earlier awareness time as compared to if they got an evacuation notice or if they found out about it by TV or other means. I also found sociodemographics to be very important. So I've in general found that white and people making over $50,000 a year, they had much earlier awareness times in the community. People who were older than 65, they had later awareness times. And then looking at sex, I found that males, they had longer delay times, which agreed with a lot of the literature that I had read. And smartphones were also found to be pretty important. So if you owned a smartphone, you had a much earlier awareness time and an earlier departure. And then in general, we found that earlier awareness was associated with earlier departures. And then we found some interesting results with the evacuation notices, which are kind of, it's a little bit tricky to totally say anything is causal because of the towers, the cell phone towers I was explaining, they went down. And then at the same time, the evacuation program, which was called Code Red, was only opt-in. So the whole population wasn't opted into this program, only a small portion of it was. And here at the right, these are these images. This is looking at the Code Red delays. We were able, through a FOIA request, we were able to look at all the Code Red alerts and their timing, and then what the evacuation notices said. So you can see the fire actually started around 6:30, but so these lines show cumulatively all the different notices that were sent out. So you can see that there was only one sent before 8 a.m. And then you could see they're kind of clustered in little bursts. And you can see below here, I just did a really basic cluster analysis to see, well, where are the means in the different groupings of the alerts. And you can see the mean using 5 bins. The first one wasn't until 9:11 a.m. So even if people were not receiving those notices, they were still sent quite late. And interestingly, in my linear regression model, I actually found out that if people received an evacuation notice, that was actually associated with a later departure and more delay. So it's just interesting how the evacuation notices in this no notice event, they weren't actually that effective. And then another part of my dissertation is evacuation modeling of the campfire. And I decided to use an agent-based model. And that's something I was pretty excited about because I would be able to incorporate behavior at a really detailed level through programming agents and how they behave. And I was able to incorporate the data that I collected in the survey into my model. And the way that I did that was first I found out I looked at travel time, I looked at the awareness time and the departure time, and I did classification and regression tree models to find out which factors were most important. And down in the bottom here, this is looking at awareness time. And so if I break it up here, I see that age, income, smartphone, and gender are the most important variables for explaining the awareness time. And then from there, I created equations through linear regression that were going to inform each agent. So each agent in the model has randomly assigned sociodemographics and attributes. And then based on those that are randomly assigned, I can, based on these equations that I've developed for the awareness time and the departure time, I can tell, I can basically program each agent like when they're going to be leaving and everything like that. So the outcomes that I was interested in this model were evacuation travel time. So when can we get, how long does it take each agent based on all their little attributes to actually get to a designated shelter? And what is the proportion of the safely evacuated people? So basically, how many people can safely exit the urban fabric and what percentage actually get trapped there? And up here, you can see some different visuals of this model, and the stars are actually the shelters. So we have them, so basically we have them finding the shelters by the shortest path algorithm. And we placed the agents, we were able to upload, in addition to the road network, we also uploaded the structures, shapefile of the structures in Paradise area. So we randomly assign the agents to different buildings, and then we connect those buildings to the road network. And then, so that's how the agents get connected to the road network. And then from there, their destination is going to be a shelter. So that is how that works. And then these are some preliminary results that we have from this modeling. So using this model, I was really interested in some different specific scenarios. So I was interested in a loss of communication, which we actually saw in the campfire because of the things that I mentioned earlier. I was interested in that, and I was also interested in the delay in the awareness because we found out that awareness was so integral into when people were deciding to depart. And then I wanted to look at decreasing vehicle access. So when I was doing a lot of these interviews, a lot of the people, either they didn't have vehicles themselves or their vehicles got stuck on the way. A lot of people's cars overheated and they had to kind of start walking basically or jump in vehicles with other people. And I wanted to look at if we are decreasing the vehicle access in the community, what is that going to be doing to those outcomes I'm interested in, the number of people trapped in the urban fabric and the travel time. And then I wanted to look at a combination of all these different scenarios into one. So I'm just presenting the findings of one of the scenarios here, which was the decreasing vehicle access. So you can see here at the right, so the base case here, which was around 90% vehicle access. So those are some of the outcomes we have from our simulation model. So here at the top, we have travel time. And then this is travel time versus departure time. And you can see as we go to the right here, there's increasing levels of vehicle access. So the base case is 90, and then one square over, we have 0%, and then it goes all the way up to 100%. And you can see which is, I mean, it's obvious that it would be harder to evacuate if there's less vehicles, but it's important to see by how much. You can see here there's a lot more variation in the travel time when we have 0% vehicle access. And you can see at 100%, oopsie. it starts looking again like the base case in travel time. And then down here, we are actually looking at the number of agents who are trapped in the network. As you can see from the base case, if we go down to 0%, we have a lot more who are trapped, and that's the same for 30%. But then if we go up to 50% or 100%, it doesn't actually look that different than the base case. And then here, again, we're looking at the differences in travel time, the differential between walking and having a vehicle. So you can see, in general, the cars have lower travel time by quite a bit, which is expected. And then in the next slide here, these are some preliminary results, so I'm still thinking through them. But we're looking at travel time by income, by the different levels of vehicle access. So here we have if you're making $50,000 a year or not. So for those, you can see they have a slightly lower travel time, which was what I found out in my first paper, that they have earlier awareness and departures for people who have higher incomes. But actually we see in these different cases that there's actually not that much difference between the different income groups. And again, these are just the simulated results of our model. It's not anything directly empirical from the data that I collected. It's the simulation results. And then again, over here, I do not see much difference between the income groups. And then here I was looking at race again. And we do see that at the 0%, that people who identify as white or people who are white, they do have lower or faster travel times. But then as we start increasing the vehicle access again, there isn't that much difference. And then here again, with the number of people who are trapped, again, we don't see too much of a difference with race. Okay, I'm gonna go on.
Sarah, so, we're getting close to the end.
Okay, I'm gonna wrap up then.
Okay, great.
Thank you. Okay, thanks. So given these questions that, that I've presented, there are a lot of different equity considerations. To kind of just reiterate those, how people are becoming aware of the fire. There's income, smartphone, age, and race, which we found to be really important in this specific community. Departure timing, again, was impacted by the awareness, smartphone, and then I didn't mention this, but how long you lived in the area. If you lived in the area, you actually left later. And then with the stuff I was showing you with evacuation modeling, we can actually see how different demographics are actually being affected, and if we have these different scenarios. And then I have some research in progress that is looking at that second survey I mentioned, which is looking a lot at the housing issues of where people are moving after these huge no-notice wildfire events. Are they moving to more fire-prone areas again? And what factors are associated with having to live in more fire-prone areas post-disaster? And I want to look again at the housing that people are living in and how at risk those housing units are, and if those units are closer or farther to evacuation routes and the effect of congestion.